Support the production of more videos by visiting the Support Moof section on my website. The link is in the description below. Thank you and enjoy.
So when we're talking about atoms of elements, there are certain conventions that are used. And so when you hear about atoms and elements being referred to, we'll often see this sort of situation here, this AZX thing. What the heck is this, right? The X will be the atomic symbol of that element, okay? And it's usually one or two letters, either the first letter of the name of the element, the first two letters, or the first letter and some other letter, or some letter in the name. And sometimes it's for a different language. So we'll see for hydrogen, for example, its symbol is H, and for carbon it's C, right? So it's just the first letter. For chlorine it's Cl, right? So the first letter and then a letter that comes in a little bit later. And then for sodium it's Na, which comes from the Latin natrium. Okay, so that's what the X represents. Now A and Z are both numbers. Z is the atomic number. The atomic number. And the atomic number is equal to the number of protons in that atom, right? And this is very, 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 very important. This atomic number, the number of protons in an element, that is what defines the element. That is what defines the element. Okay? That's very important. So if an atom of an element has a certain number of protons, that defines the element. We'll talk more about what that means in just a second. Also, I've got these little asterisks here by atomic number. That atomic number is also equal to the number of electrons in that atom. Now, why would that be? Well, because you're talking about equal and opposite charges, right? Atoms are electrically neutral. We mentioned that in the previous video. They are electrically neutral. Now, I do want you to take care to pay attention to this note. It is possible for the number of protons to not equal the number of electrons, okay? But then you don't exactly have an atom. What you have is an ion, okay? Which is, in layman's terms, a charged atom, okay? We're not going to really talk about that right now. We'll talk about that later, okay? Anyway, so that's what Z is. Z is the atomic number, okay? And so for hydrogen, it is 1. For carbon, it is 6. Chlorine, it is 17. Sodium, it is 11. Okay. A, number up here at the top left, is the mass number, sometimes referred to as the atomic mass. Okay. What it is equal to the number of protons plus the number of neutrons. Okay. So the number of protons, that's Z, right? That is Z. So let's write that here. That is Z. And if we said we could refer to the number of neutrons as being N. Okay. So if we say that N is the number of neutrons, how would you find N? Okay, well, this is basically an equation here, right? A equals Z plus N. Okay, so A equals Z plus N. And then we just solve for N, right? Solve for the number of neutrons. So we would just subtract Z from both sides, and then we would have N is equal to A minus Z. And that would be it. So if we know A, we know Z, we can find the number of neutrons. Okay? So just to be completely thorough here, N would then equal A, which is the mass number, right? Minus Z, which is the atomic number. So the number of neutrons would be equal to the mass number. The mass number is the number of protons plus the number of neutrons, right? And we'd subtract the atomic number, which is the number of protons. So if we think about that, number of protons minus the number of protons, we're just left with number of neutrons equals the number of neutrons. That checks out. Okay. So basically N equals A minus Z. Oops, let's highlight that a little bit better. N equals A minus Z. So let's put some A's up here at the top for these examples. So for hydrogen, we're going to put 1. Carbon, we're going to put 12. Mass number for chlorine, we'll put 35. And for sodium, 23. So we've got A's up here at the top, Z's down here. And then to find N, we'll just take A minus Z, right? So the N here we'd have 0 neutrons in that atom. This atom would have 12 minus 6, which is 6. 35 minus 17, which is 18. 23 minus 11, which is 12. So we just found N for all of those. Okay. Now, another question that comes up is, what if I wrote O with 16 up here? That's all I wrote. What's the atomic number? Do I have enough information to answer that question? Okay. Well, earlier we said that Z, the atomic number, defines the element. Okay. If we know what the element is, all we have to do is look on the periodic table. And if you look on the periodic table for oxygen, its atomic number is 8. Oxygen has the atomic number 8. O's Z, its atomic number, is 8. Always. If you have an atomic number other than 8, you don't have oxygen. But if you do have an atomic number of 8, you have oxygen. Also, if you have oxygen, you know you have exactly 8 protons. Okay? Okay, so this is very important to remember. Okay. Another thing I want you guys to kind of take care to note is that I wrote this just as O with the 16 up here, and that's fine. You can do that because if you know you have O, then you have to have 8 protons. So you can actually say, so 16 with this oxygen here, this is said out loud as oxygen 16. Okay, oxygen 16. So if we had uranium 238, that would be written as U for uranium, 238 being the mass number. And then down here we don't have to write anything, but we could write it as that same thing. So we just copy and paste that. That might have been easier to just write it. Whatever. Okay, so we'd have that, and we could indicate 92 down here. But these are both the same thing, right? Because uranium, whether written explicitly or not, if it is uranium, it has a Z of 92 for sure. It has 92 protons exactly. So these are the same thing here. Okay. So below, I've got some questions here that we should answer. First one, can the atomic number Z of a particular element change without changing the identity of the element? Without changing the identity of the element. Okay. Well, the answer there is no. Because we said that the atomic number Z, the number of protons, defines the element. The number of protons defines the element. So if you change the Z, then you're changing the element. So this is not possible. Second question, can the atomic symbol X of a particular element change, again, without changing the identity of the element? Again, no. This is kind of just a different way, right? If X equals, I don't know, sodium, Na, then you have sodium. If you change the X, you no longer have sodium. If you change the X to N, then you have nitrogen. That's an entirely different element. So Z and X are kind of two different identifications, right? It's kind of like having two ID cards. It's like a driver's license and a social security number. Like they're both for you specifically, right? And no one else. Okay. Last question here. Can the mass number of a particular element change without changing the identity of the element? Now this one, the answer is yes. Okay, this is yes. So you can have a different mass number, A, but have the same Z value. Okay. What would that mean? That would mean that you'd have a different number of neutrons. We'll talk more about that later. If this is the case with an element that you're talking about, you have what's called an isotope. Okay. Isotope. This is something that's pretty important. and we'll see this in the next video. So I hope that video was helpful. Thank you for watching.
If you found that video helpful, don't forget to hit it with a like and subscribe for more content. Also, follow Moof University on the different social media, links in the description below. Thanks and happy studying.